Hello. Today I'm going to talk about the paradox of the positive. Well, that's the title of my talk. The phrase is not due to me, but the topic of the talk is really exploratory tools for visualizing the individuals in multivariate longitudinal data. This is joint work with Dr. Nick Tierney and Dr. Tanya Pravan. And this is one of the talks as part of the International Biometrics Conference in the virtual learning series in July 2020. If you'd like to follow along with my slides are available at this link. If this link is too long for you, just go to my webpage, diecook.org, and you'll find a link to the slides for this talk there. I'm going to start with some motivation. This is quite old work I'm really starting to talk about today. At least the motivation is quite old, but we haven't really fully resolved, or I don't feel like we've fully resolved the work yet, and that's the topic of today. So here's a plot that is very similar to plots that you might find in the book by Singer and Willett, which is a long and comprehensive book on applied longitudinal data analysis. This is one of their examples. And although it's not entirely appropriate for this audience, it's still, I think, it still is the best example to illustrate some of the techniques I want to show today. So bear with me with this example. What we have is years in the workforce. So on the horizontal axis here, we've got experience. That means the years that the person has been in the workforce. And then vertically, we have a log wages, so they're hourly wages on a log scale, on a natural log scale. And this is the fitted model, where the fitted model has been, there's some demographic information that's been used to fit the model. It's a multi-level model where education up to 9th grade or to 12th grade and some race characteristics were shown. What you'll see is that that fitted model suggests that there's a difference between education level. The higher education level, which is the top two lines, 12th grade, have generally higher wages, hourly wages, and that increases over time the longer you're in the workforce. There's a similar pattern for the 9th grade education. And in each case, if your race is black, then you would be doing worse off overall. The slope's not as high, and which means that wages don't increase as well for throughout the years of experience. I should say that this data comes from the National Longitudinal Survey of Youth. That's where Singer and Willett got the data. And that data, and these are high school dropouts that were in this cohort of people. So that's how I came to the data originally, and I wanted to show you one of the things that I did. In some of you might remember the GGOBI package from many years ago. We were developing GGOBI between 2000 and about 2010, 11, 12. So I've taken that data and I'm browsing over the profiles. Let's see if this starts playing soon. I'm going to browse over the profiles in the, yeah, here we go. Come back to a little bit earlier at the start. So I'm just going to highlight individuals and show the traces of individuals and show their wage experience for that same data. So all of the data is plotted in purple. It's different from the fitted model as a reason not to show the entire data because it's a mess. And these orange dots correspond to individuals, and we're rapidly scanning across the measurements for a single person. Let's watch this for a while. It's quite a lot of individuals. I've also got, there's more information in terms of scanning according to different criteria here, but if you want to look at that video yourself, it's on the GGOB website. It's one of our example videos related to this data. The main message from looking at the data that way is that it kind of rains on our parade. The variation from individual to individual is much greater than the overall trend. And while that overall trend kind of matches our common belief that at the longer you're in the workforce, your wages should go up, the reality is that many of the individuals, particularly in this data set, had quite a different experience. There's a huge amount of variability from one person to another, and that's the main structure in this data. So it comes to this issue, I think that's very important for today, is that as statisticians, if we have this choice of making statistics for policy or statistics for the public, I think these two are diverging purposes. And statistics for policy would mean that if I have a demographic group that's disadvantaged overall, I need to make strategic decisions as a leader in order to improve the experience of that group. But the problem is, if that group is a very diverse range of measurements, which is almost universal when we're working with people, that the individual is vastly different from their demographic, then what a person sees in your report may not be what they've experienced. And it leads to this dichotomy of senses. So let's, so this comes to the main sort of philosophy behind what I'm talking about today. The phrase paradox of the positive was coined by two people fairly recently, Heath and Waymer, and they have phrased that in reference to Frederick Douglass's speech on the 4th of July in 1852, called What to a Slave is the 4th of July. So this is the piece out of Wikipedia. Douglass orates that positive statements about American values such as liberty, citizenship, and freedom were an offense to the enslaved population of the United States because of their lack of freedom, liberty, and citizenship. And this is the issue for us. If we make statistics for majority classes or for broad demographic groups, we're missing and not recognizing what happens on an individual level. Right, so something, and the paradox of the positive speaks to this. So something that's positive for a large group can exclude individuals. Now, and I think an example of this is a tough example, I think, and I hate to bring up the name, but we've seen in the USA a number of issues related to COVID-19. And while we look at the data ourselves, we might see, if you look at the death rates of typically banded about 1%, roughly, it changes based on different sort of demographics on average. But if we think about 1% from our own perspective, in a way it's calming in the sense of, look, I shouldn't worry and panic and make a bunker for myself, because the odds that I am going to be suffering are probably fairly tiny, particularly when we also consider the rate of infection. But for a leader like Donald Trump to say, oh, it's only 1% of the population that's going to pass away, that's a real dereliction of duty from a leader's perspective. So this is a type of dichotomy that I'm talking to, that kind of statement means that I don't care about 1% of the population, which could be several million people in the United States. Another comment that I need to make here as well relates to the use of race as a measured variable in many demographic studies. And there was a very interesting tweet by Melanie Wall from New York, biostatistics at Columbia, recently, pointing to an old study that asks the question, if racism is the problem, why don't we study racism rather than race? Because we're all the same, and that is an artificial dichotomy. So there's some very early history from about 20 years ago of public policy statements along these lines, and you'll find that in places, particularly in Europe, measurements on race are not recorded. It's not the case in the data that I'm using for the wages today, but we're going to not use it again for the rest of the talk. So I'm going to talk about new tools for longitudinal data that help you to explore individuals. And these are in the R package blogger that you can play with yourself by downloading the package from CRAN. So let's talk about the data. It's a little bit of the data structure. So the Brolga package builds on a data structure called Sybil by Iro Wang. And a Sybil has additional context and structure that can be utilized in making calculations. So a Sybil recognizes that I'll have a time index and I may have a key. And so in this case, the key would be the individuals or the subjects in the data. And in this line, the top here, I've got, there's 888 individuals in the wages data, and they are in the variable ID, which is the key for this data. The time index is actually the XP variable, which is the third one along here, the XP variable. And you'll see in the Sybil summary that there's this exclamation mark at the top. That exclamation mark indicates that we do not have a regular time series. So if this time index variable had a regular interval, Sybil would detect that and tell you what that regularity is. That exclamation mark means that you don't have a regular interval for this data. Right, so let's take a look at the data. We can take the data and pipe it into ggplot and plot the experience on the horizontal axis and the log wages on the vertical axis. And we're going to use a geom line where lines are drawn for each individual. I've got a special theme here that sets up the color to match my slides. So the big thing is it's just a mess. And this is often the case when you're working with longitudinal data, that you end up with a pile of spaghetti. And I love this title because this is from Nick Tierney's explanation, Making Spaghetti. And you know, when we're eating spaghetti, it can be quite messy, particularly with young kids. And this is an example of a really messy eater. I've got some great stories myself from feeding my son spaghetti and the problems that we had, but that can be for another time. So we want to go from a spaghetti mess to a little bit more controlled spaghetti handling. There's quite a difference here. You see how very carefully, it's still messy, but very carefully she's grabbing little pieces and digesting small chunks. And if you get really advanced, you might even be like Buster Keaton and be a very tidy eater of spaghetti. Righty, so let's come back to the wages data. So I said it's not regular. So one of the things that we might do as a first step is to examine just how irregular the data is. And the first thing might be to compute the number of observations per individual. So to do that, I'm going to take, use the features function, and it knows to do number of observations. So based on that Sybil data structure, we've got the key, which is individual, and this is calculating the number of observations per individual. I'm going to make just a bar chart of this. And you'll see that there really are quite a different number of observations per person. Maybe on average is about seven measurements per person, but some people, there's a couple of people that have got 13 measurements, and then there's quite a few people that only have a single measurement. We could also use that data if we want a slightly cleaner data set. We might use that variable. I might just add that variable to my data set using add nobs, and then I could use that to filter just the people that have got at least more than three observations. Right, so I've got nobs in my data set now. Now, not all subjects start at the same time. So we can extract that information and check that information, again, by using features function. And if I calculate the minimum time point, which is the minimum experience in this, so I'm doing this calculation on the XP variable. I'm calculating the minimum of that. And here's a histogram of the minimum. I've set the limits to make sure it goes through the full time series of the data. So there's 13 years of time in this particular data set. And you see that most people started the study or their experience started very early, but there's a few people that were not measured until about 5 years into the study. So there is a little bit of a difference to the starting time in terms of measuring experience in the workforce. Here's another one. Let's take a look at the range of experiences. And so just the time variable, whether we're measuring people from 0 time to 7 years or from 5 years to 13 years, what's that range of experiences? And you see that it's quite varied. There's a lot of people that were only measured once, and so the range of experience is 0. It's a little bit of a peak at 0. And then it sort of bounces around. It's pretty uniform, maybe a little bit of a peak around 7 or 8 years in that time variable. Okay, so now let's start to actually take some structure to the data. So I'm going to call this taking small spoonfuls of spaghetti. And you can do this using the sample and keys function. And if we take a sample of size 10, here's our first sample of size 10, and you'll see most of these profiles are fairly long. So these individuals in this sample of 10 are fairly long and sort of increasing over time. There's one profile at the top that's got fairly high log wages, and they drop out of the study about 7 years of experience. There's also a smaller profile here that drops down a little bit over time, over a short period of experience in the workforce. I should also mention the wages conversion here in terms of the vertical axis. So around about 0.5 is $1.65 per hour in wages, and a value of 4.5 is $90 per hour in wages. Let's take another sample. So here's another sample of size 10. You'll see that there's a person here that's got a big increase in wages around mid-career, and then it drops back down again. You've got another one that sort of steadily goes up over time, and you've got some more that bounce around, and then also some short series. Let's take a look at another sample. Okay, so we can take smaller chunks of the data in order to tease our way through the 800 individuals. We could mix this with our N observations and take spoonfuls of different lengths. So I'm going to take only the individuals who've been in the study for a longer period of time. And those will be the longer traces. So grabbing the longer strands of spaghetti. You see most of these people in this sample, again, just a sample size of 10 still, a sample of 10 of the longer series, most of them are sort of increasing. There's a couple that are bouncing around a lot too. I could take the inexperienced individuals, so I can take just some of the shorter series. And if we do that, we don't really learn very much with a smaller series, but you'll see that there's a bit of individual bouncing around between a couple of measurements and some fairly steady over that time frame as well. And I could take some medium experienced people by just choosing the people with a number of observations between 5 and 7. And so different ways of breaking up the data into different samples in order to work through a fairly small number, 888 observations. That still is kind of messy. A couple other ways that we can break the data up into chunks to get a head around all of these individuals. One method is facet strata, where we take the full set of 888 people and divide them into, say, 20 plots. That's still way too many really to look at in one plot. There's still a lot of individuals in each plot, but if you had a smaller data set, that might work nicely. So it'll take the whole set of observations and break them into equally portioned chunks. And then facet sample, which I've got an example of across the page, show most of the pot in, so samples of the pot in neatly separated portions. So I'm taking samples of size 3, and that gives me about 60 of the 888 people if I lay it out this way. So this is the facet sample. I've set the number of individuals to show in each facet to be 3, and I've set the number of facets to be 20. So we can get some idea of the differences from one individual to another. So what do you learn about this? It's the same message that I would have learned from the random profiles being shown in GGOBI rapidly. This is a little bit more orderly way of getting a head around what the measurements are for all the different individuals. And so you'll see that there are some individuals that have a pretty steady wage. Some of them are increasing, some of them are fairly flat. Some of them go down, some of them bounce around a lot. Some of them are fairly short, some of them fairly long. So that sense of variability from one individual to another, you can see from making these charts. I'm going to jump to a different direction again. And the first parts that I've shown are fairly straightforward. This is sort of just quick ways of breaking up the data into smaller parts to understand what we're working with and what the overall patterns are in the data. Now, another approach is to develop something like cognostics or scagnostics, something that we're calling longnostics, statistics that are calculated for each subject. So for each person, we might fit a simple linear model and record the slope and the intercept from that linear model. We might also extract the standard deviation from that model, or we might separately calculate the variance of the response and the standard deviation of the response for each individual. I might also do something like calculate the jumps. So what's the biggest difference between wages for one person from consecutive time points or just generally across the whole time frame? Maybe I organize the data into more standard time by smoothing the time and then differencing the values for each person. So any statistic that we calculate for each subject, we're going to just label those as longnostics and then use those statistics to organize the data in different ways. So I'm going to just take the slope variable. So here we're taking the wages data, we're piping it through add-in observations just because I don't want to do these longnostics for a really short time series. I'm only going to calculate the longnostics for subjects that have at least 4 measurements. And then I'm going to add a slope statistic to the data, and that slope statistic is calculated by doing a regression of the log wages on experience. That means it's for each individual, we're feeding a simple linear model. And then I'm going to use that slope from that linear model to select individuals to look at. So once I've got this statistic added to the data, I'm going to select just the individuals that have a slope bigger than 0.4. That 0.4 seems like it comes out of the blue, but I've done a quick 5-number summary of the slopes and found, what's the top end of the increasing wages for a person. And so 0.4 gives me these 4 individuals. So these 4 individuals would have a general slope from a linear model greater than 0.4. So all of these individuals have an increasing wage experience over the time. I can do the same thing in terms of looking at people that have had a negative experience in the workforce. So I'll take that slope statistic and choose just the individuals that have a really low slope. Yeah, minus 0.7 is quite a lot lower than the highest positive. So the negative slopes are a little bit smaller than the most positive slopes. But the slopes generally are not normally distributed, so that there's a bit of a skewness to them. Most of the slopes are 0 and above, but the negative slopes, there's a few individuals that have quite had a big slide in their wages. So these are the 3 individuals that have the most negative slopes. And you'll see that really what's happened to those individuals is that they've bounced around in their wages over that time period. And one of the 3 has had a fairly small series in this data set. Okay, so using longnostics, I can reorganize my data again in different ways, and then tease apart, the most extremes on one statistic and then the most extremes on another statistic. Again, it helps me work around this large collection of measurements. Now, here's another way to look at it. So we know about the 5-number summary, and with the 5-number summary, you'd pick out the min and max and the Q1 and Q3 and the median. Now, what does that mean for longitudinal data? And here's what I think is a nice way to look at it. We want to pick out the individual that's closest to some statistic, maybe the average. So we calculate the average slope and we find the individual that's the closest to that average slope, or we find the individual that's closest to the 25th percentile or the median, and then we show the traces of those individuals. So I'm calling this, it's a different style of 5-number summary. So think about it as these different kangaroos. Which one of them is closest to the average of the 3? Maybe this one on the left is more the average of the 3 of them. The one in the middle is a bit bigger and the one in the front's a bit smaller. So we're finding the statistic, calculating some statistics of those statistics, and then finding the individuals that are closest to those and representing the data in terms of those individuals. So for the individuals, I'm going to find min, median, and max in a 3-number summary. And this uses a function in the package called keys near. So here's that example. So I'm generating the slope again, and I'm using the keys near with the function 3-number summary. So that 3-number summary gets the min, the max, and the median. And I'm showing it here, these 3 individuals, this darker line, this is the individual that's closest to the median slope. And this slightly darker purple of the 2 lighter purples, the slightly darker one is the individual that's closest to the maximum slope. And well, it probably is the individual that's got the maximum slope. And the light purple one is the individual with the minimum slope in the data set. The purpose of this is to get the sense of the big range in terms of that overall trend across individuals. And so this overall median, maybe it's got a very slight increase in slope over that time, but it's pretty flat. It bounces around a little bit, but sort of across the board, that individual's wages sort of roughly increase a little bit on average. The person with the highest slope has really got quite a nice increase in wages over the time frame. And the person with the most negative slope has quite a lot of volatility in their wages, but generally their wages have gone down over the time. The min and the max, they'll also have very short traces. And to be careful about time here too. So that's, I've shown just a 3-number summary because showing them on the one plot gets messy. And an interesting piece here is that the color scheme that I'm using has a stronger middle value, and the two away from the middle, we've sort of got a pyramid scheme in terms of color scale. I've made them a little bit different so we can see the differences between the min and the max. So it may be easier to make these in separate plots. And so this is now the 5-number summary for the wages data, and plotted in separate facets. So the middle one here should be the same person as shown here. It is the same person, it's just the horizontal axis has been squished in a little bit because the third quartile, person closest to the third quartile has quite a long experience, and that's setting the scale on the horizontal axis for everybody else. So this way we can get some sense for the minimum is a really quite negative decline, even though it's a short time series. The first quartile is actually pretty flat. So by the first quartile, most people are experiencing a pretty even wage experience over the time frame. The median is slightly increasing. The third quartile, there's quite a large increase, and the max is much large. So the middle 50% of these people pretty much have a positive wage experience. Okay, so let's move on again. Now let's talk about sculpting. I'm sorry, I like the idea of sculpting spaghetti. So this is the interplay between modeling and exploration. So I'm going to fit a mixed effects model to this data. Education is a fixed effect and subject is a random effect, where we're also taking into account slope, allowing slope to change from one individual to another. So I'm using the LME4 package to fit the model, and I'm adding my predictions and residuals to my data set. And here what I've done is plot the predicted values. So I've got years of experience horizontally, log wages vertically, but in here I'm now looking at the predicted values for each individual instead of their raw values. We can do that quite easily. What do we see? It's a little bit more organized. It's a little bit like uncooked spaghetti. It's all straight. That's just because of the style of the model that I put together. We see for the most part, they're mostly all sort of standing up a little bit. That's kind of what we saw before with the 5-number summary. But you do see that for some individuals, they're sort of going in the opposite direction, that their wage history has been over the years declining in value. Let's take that a little bit further. So we can also use this to make plots of the data as well as the predicted value. So I'm going to, I'm showing the predicted value here. I'm just going to select a small number of people and look at the fitted model against their observed values. Right, so I'm making points of their actual observed wages value as well in order to make this chart. So 12 individuals, and here's their fitted value and their observed value. And you see for the most part, although there's a lot of volatility from for some individuals, for the most part, those models fit very well, except for some. So it's a little bit underfitted for patient or subject 2135. For subject 5635, this is an individual whose model fit has traumatized me for years. So this is one of the individuals that I identified using GGOBI a long time ago. And this is really traumatic. right, their observed values have a most amazingly smooth negative decrease, very sequentially stepping down a small amount each time. And the fiddle model is flat. It's really distressing to see that one. It means that for some individuals, the model fits pretty bad. And being able to detect that is actually a really useful feature of this approach to working with the data. Now, I promised, I'm running close to being out of time, but I promised multivariate in my title, even though it's parenthesized. I want to just give you a hint for what we would do if we do have multiple responses, because this is my fun area of work. Right? So if I've got more than one response, and I'm going to just generate some for this data. So I've got log wages, and let's say I've got expenses, and let's say I also have savings. I just simulated those two variables. This is all that data together. And you see with my simulation, I've made a pretty strong a negative correlation between wages and expenses, and a pretty strong positive correlation between wages and savings, but it's not normal. It's a bit of an exponential simulation I've used. But so this is over all the subjects, over all the measurements. Those three response variables have some association between them. Actually have pretty strong association between them just by design for now. But just suppose you're working with your own data and you've got multiple variables. So now if we want to take a look at how individuals look in this situation, we can do something like this. This is really a leap up in terms of the content that I've talked about so far. I'm going to use the tour package, which allows me to take multiple variables and high dimensions and just rotate in those high dimensions. I've only got 3 response variables here, so it's not very high dimensions. It's just 3 dimensions. We can manage that. So I'm taking the data and I'm selecting just some individuals, 2 individuals. The code's very messy, and it would be nice to make some nicer way of making the code, but don't stress about this code. The last 2 lines allowed me to make these animated GIFs. So let's work our way through this. I've got the 3 variables, and I'm just looking at 2-dimensional projections of the 3. I'm just rotating those 3 variables, and I've got the profile of one subject highlighted. So the profile of subject 12227 is highlighted in here. So overall, the association between those 3 variables is pretty elliptical. It's a little bit smeared out in one end, and it's in one direction on the side as well. But this individual's association between their measurements doesn't quite match that overall correlation between the variables, but it's still fairly condensed. That individual's measurements are still around about the middle of all 3 measurements for all the time that they were in this study. Let's take a look at another subject. So in comparison to that, here's another subject. And so this subject has had a very volatile experience. It has very volatile measurements, and particularly one measurement is almost off the scale of regular data. But the variability is almost as variable for this subject as for the entire data set. Whereas for the first individual, their variability was quite small relative to the variability of all the subjects for those 3 variables. So in making these types of plots, what we're looking at is a little bit like you would do in any type of association when you've got a categorical variable. You're comparing the association for category 1 to category 2 to category 3. In particular, it's sort of related to Simpson's paradox, right? If you're looking at multiple strata in your data, you care that the association between the whole is the same as between the levels of the strata, or in this case, from one individual to another. Alrighty, I'm almost out of time, so let me jump to a couple more little pieces. So lastly, I'm really sorry about the wages data. It's like getting moldy spaghetti. But it's moldy spaghetti for various reasons. Even though it's messy, it's too clean. And this data has been bothering me for many years. Let's take a look at why it's a little distressing in a way. So it's messy. So it's an interesting problem to get your head around, but it's too clean. The original cohort of people was on the order of 12,500 people. This data set has only got 888. The process that was taken to go from 12,500 down to 888 is not transparent. It was not clear what's been done. And the demographic groups have very different numbers. I'll just flip across and show you one example. So if you look at the individuals from the very first picture that I showed you, from 9th grade education to 12th grade education, there's very few subjects with the 12th grade education. And so that model was fitted on a very small subset of the data. Most of the individuals have got 9th grade education. So it makes me a little bit worried about statements that could be made in terms of education there, because we're modeling on the small sets. So I've spent quite a bit of time from time to time trying to extract that data. I'm almost there in terms of trying to refresh it up to most recent years. So the study started in 1979 and it's still continuing. Most of those original people in the study will be almost out of the workforce now. They mostly will be retired. My current set of data, I can extract 6,000 individuals that are reasonably complete, but there's a lot of problems in the database itself. There are individuals that have time, sometimes have got on the order of $10,000 per hour in their hourly wages. There's from wave to wave of this study, there's different encoding of the variables. All of this makes it really difficult to extract the data. And so one of the messages here is actually having some honesty in the way that you pull a data together from the original source, and keep a paper trail so that we know where and what decisions were made in making that data. And as statisticians modeling, it's very important to be clear on those strata in your data, and making any kind of analysis on data that's flawed means people are still going to make inference based on those longitudinal models that were used in Singer and Willett, still make us feel like we then apply them to our general world, because we're talking about people like us. And I think that data actually cannot be trusted in any sense. So just wrapping up, the individual approach that I've talked about today, actually it's you see it used from time to time. An example from today is the New York Times coverage of COVID-19. And so you go to the COVID coverage in the New York Times and you'll see charts like this. They'll show you a whole bunch of individual series by state or by county or by country, and they'll group them into which ones are increasing. Now, how you calculate increasing is really, really tricky. And I'm glad to see that they have some trouble here too, because if you look at all of these states where their class is being increasing, well, some of these numbers are pretty small overall. And then they've got another group of where the states, it's mostly the same. You might think, I look at Arizona here and I think, oh, that's decreasing. Why is it down in this bottom group of where cases are decreasing? It's just, it is pretty hard to numerically define increasing, decreasing, or stable generally for data like this. But point is that this individual approach, it's in common use in some areas. And I think that's useful for us to take note of as statisticians as well, because I think it's really important generally. So here's what I hope you have learned or heard today. Here's what I hope you've heard today. We need more research, and acceptance of methods that can communicate the individual experience. When the variation is large, summarizing the variation is the honest thing to do. If we only focus on the overall trends, I think we have a potential to be misleading people and making people feel that anyway, so it's that paradox of the positive. I think that we are not speaking to what an individual experiences, and it's a gross disservice. And lastly, as statisticians, as a field, I think we need to address this individual experience so we can better engage with the public. And I think this is really important for evolving democracy, literate citizenship, and particularly as more tools become available, people will do their own work. We need to be a part of that. You can read more about Brolga at the Brolga webpage. This is the lovely Brolga bird, and Brolga stands for Browse over Longitudinal Data Graphically and Analytically in R. And some last acknowledgements. So all of my slides were made with the R package Sharangan. I specifically made an iris theme for some statistics work, and that theme was adapted from the Sharangan thema. It's using Knitr and R Markdown. The slides are at this website. I've talked before. All the supporting slides are at my GitHub website here. And so all the code that I use to generate the plots in this talk are in the RMD file on that GitHub page. Well, thanks for listening, and I'm looking forward to answering questions later today.